Welcome to Time with AB. A relation is a connection between two sets. It associates elements of one set to elements of another set. So we are finding the common thing between two sets. So assuming all of a sudden I start writing Accra. Yeah, does it ring a bell? Now what if I include this? Does it look familiar? Now let's try to get the relationship between these two sets. So this is our set A and then our set B. Now our set A is what is termed as the domain. So this is our domain, then this is our codomain. What is the relationship between these two? We realize that Accra, Greater Accra, what is it telling us? Oh, okay, so these are the capital cities of these particular regions. So the relationship is such that our set A, which is the domain, houses the capital cities of our set Y. Like this, we have Fanti mapping to Central region, we have Ewe mapping to the Volta region, then Twi mapping to the Ashanti region. What is the relation between them? Now the relation is such that our X happens to be the languages spoken by our set Y. So that is a relation. Another example. Now what is the relation between these two sets? Set Y is just X plus 1. So that means if we are to add 1, 1, 1 to the values of X, then that will give us Y. Y set is equal to our X set plus the number 1. So in this case, if we are to add 1, 1 to the our set X, that is giving us our set Y. So let's try to see. 1 plus 1 will give us 2. 2 plus 1 will give us 3. 3 plus 1 will give us 4. So that is the relation between them. One-to-one relation, one element in the domain to one element in the codomain. Now, in one-to-many relation, one element in the domain is linked to two elements in the codomain. In many-to-one relation, now there are several elements in the domain being connected to one element in the codomain. So many-to-many relation, there are many elements in the domain which is connected to that of many elements in the codomain. A mapping is a relation in which each member in the domain maps onto only one member in the codomain. And one-to-one relation and many-to-one relation are mappings. Mappings are usually described by a rule or a formula. Then we'll be treating two types of mapping. The first one being linear mapping and the second one being the exponential mapping. So we are going to use rules to find out the relationship between two sets. In a linear mapping, the difference between the consecutive elements in both the domain and the codomain is constant. So the difference will be constant throughout. And the rule for a linear mapping is the same as the equation of a line. So the rule for a linear mapping is giving us y is equal to mx plus c. Now where our m is the gradient, y being the y value, x the x value, and then our c being the intercept. So for us to get the gradient of a line, we know that is the change or the difference in the y values over the difference in the x values. So that is how we get the equation of a line, and this can be written as. For it to be simple, now let's look at it in this sense that our m is equal to the constant difference of the codomain. So the difference in the codomain being divided by the difference in the domain. Let's solve these questions. Yeah, so to solve this question, let's state the equation of a line, and it's giving us y is equal to mx plus c. Now let's find the gradient. What will be the value for m? Now we said the gradient is the differences in the codomain, the y values, divided by the differences in the domain. Now let's look at the codomain. What is the differences between them? Let's take the first two, 1 and 3. So 3 minus 1 What is the difference? That's 2. And 5 minus 3 is 2. 7 minus 5 is 4. We have 3 minus 1 divided by the difference in the domain. Now you realize that 2 minus 1 is 1. 3 minus 2 is 1. So it's 1 throughout. So that means our difference is, let's take the first 2. 2 minus 1. And that is giving us 3 minus 1 is 2. 2 minus 1 is 1. So our m is equal to 2. Now the next thing we need is the value for the intercept C. And for us to get C, we must at least get a point which has the y coordinate and the x coordinate. Now let's take any point on the line. There's a particular line, so let's take the first point, x coordinate, which is 1, then the y coordinate, which is also 1. So there's our x coordinate, then our y coordinate. So anywhere we see y in the equation, we put the y coordinate. Anywhere we see x in the equation, we put the x coordinate. And then now we found m, we can put that one also in. So our y, which is now 1, so 1 is equal to, now the value for m is 2. So 2 multiplying x, our x is now 1, plus c. Now I can see that my rule for this mapping is that y is equal to 2x plus c, which is minus 1. So I can say y is equal to 2x minus 1. And this is the rule. This rule is saying that if we are to multiply the x value by 2 and then subtract 1 from it, it will give us a subsequent y value. Now let's try the first two. When x is 1, now when x is 1, then our y will be equal to 2 times 1, then minus 1. 2 times 1 is 2, then minus 1, which is 1. Now let's check to see if it's true. Yes, it is true. Let's check for the second one. What if x is equal to 2? Let's find the rule for this particular mapping. First of all, let's state the equation of a line. So y is equal to mx plus c. Then let's find the value of m. Let's look through the y values. What is the difference between them? Now the difference between 5 and 2, so 5 minus 2 will give you 3. Let's check that of the 8 minus 5 will be 3, 11 minus 8 will be 3, 14 minus 11 will be 3. And since the differences are the same, then it's telling us that it is linear mapping.